Okay, so let's talk about a couple of problems on factored form of a quadratic. So, factored form, we're looking to change a quadratic to factors, where we can set those equal to 0 and find the x-intercepts. So let's practice on factoring. If a is 1, I don't have to multiply. I can just look at numbers that multiply to be negative 28 and add to be negative 3. Right, so when you think about that, they have to multiply to be a negative number, so 1 has to be positive, 1 negative, and they have to add to be a negative 3. So negative 7, positive 4 multiplies to be negative 28. Negative 7 plus 4 gives me negative 3. Now listen, you can use your calculator and write down all of the factors of 28. You may not get it the first time, and that's okay. Right, because x is 1, I don't have to do the AC method. You definitely can if you want to, but you don't have to. So I have x minus 7 times x plus 4 equals 0. And then I set each factor equal to 0. And I see that x equals 7. And x plus 4 equals 0. And x equals negative 4. So those are my x-intercepts. That's where the graph is the x-axis. Right, for the second one, I'm noticing that a is 5, so I'm going to multiply. 4 times 5 is 45, so I need numbers that multiply to be 45 and add to be negative 18. Well, I know 9 times 5 right off the top of my head, but I'm noticing they both have to be negative because they have to add to be a negative 18 and multiply to be a positive number. Well, negative 9 and negative 5 does not add to be negative 14. So let's try something else. How about negative 15 and negative 3? So negative 15 plus negative 3 adds to be negative 18. So those are my factors. I'm going to replace negative 18 with those two factors. So I have 5x squared minus 15x minus 3x plus 9. All right, now I'm going to factor by grouping. So I'm going to group these two together and take out what's common. I'm going to group these two together and take out what's common. I don't use parentheses to group them because of the negative sign that's in front of the 3. All right, so I take out a 5, and that leaves me, so taking something out means I'm dividing this by 5 and an x. Let me back that up. There's a 5x that's common to those two. So that means I'm dividing each of these by 5x. So that leaves me x minus 3. All right, so I need, when I factor out from here, I need this to read x minus 3. Right now it's negative 3x plus 9. So I'm going to factor out a negative 3. So I'm going to divide this by negative 3 and this by negative 3. So negative 3x divided by negative 3 is positive x. 9 divided by negative 3 is negative 3. Okay, do you see how I have this term and this term, and they have common factors? They have a common factor of x minus 3, so I'm going to factor that out. Gone and gone. Do you see what's left over? I'm going to put that in a parenthesis together. All right, so there's my factors of the quadratic. All right, now let's talk about solving. So either one of those two at the top, the next step to solve would be setting it equal to 0 like I did here. We were just supposed to factor these, but I just went ahead and solved. So I would do the same thing here, set it equal to 0, set each of my factors equal to 0, and solve. But they only asked me to factor on these, so I could have stopped on that one there and here. But solving, I mean, you still have to do those steps of factoring, then set it equal to 0. All right, so let's look at number 3, because it is not set equal to 0. So since this has an x with it, I am going to set it equal to 0. So I'm going to subtract 9x from both sides. And then I'm going to take out the common factor of x. So I'm going to factor that out. So I divided both terms by x. And now I have products. I have two things multiplied together. So I'm going to set x equal to 0. So there's one of my x-intercepts. X minus 9 equals 0. So there's my other x-intercept. All right. I could graph this parabola now. So I have an x-intercept at 0 and at 9. Right? So there are some things we could talk about. A is 1, so I'm just going to sketch. I'm not going to find the vertex, although you could, right? I can go halfway between the two. So 0 plus 9 divided by 2 gives me the x value that's halfway between, and then plug that x value back in and find y. And I'd have the axis of symmetry also. So another question that they're going to start asking on number 13 on the paper that you're doing is, where is this parabola above the x-axis? Where is it below the x-axis? So I'm going to remind you on this one, and then I'm going to work number 13 with you. All right, so if it just says to solve, I can stop here. But if it asks me about where's the graph above or below the x-axis, or where is it positive or negative, I'm targeting these x-intercepts. And I'm looking to see if they want positive, where is my graph above the x-axis? So my graph is above the x-axis from negative infinity to this x-intercept, and from this x-intercept to positive infinity. My graph will be above the x-axis. So it's above from negative infinity to 0, and parenthesis on 0, not a bracket, because it's actually 0 at that x-intercept. And also from 9 to positive infinity. Where is it below the x-axis? Let's do a different color for below. You think about that while I'm changing colors here. Where is it below the x-axis? So I'm going to trace my graph where it's below. And I'm going to go look back up at the x-axis. It's below the x-axis between those two x-intercepts. So between 0 and 9, it's below the x-axis. So you'll just have to check out the question and see if it says above or below. So this is number 13, so you can work number 13 with me. All right, so it says it says where is the graph on 13? Let me go back to it. 13 says where's the graph positive? So where's the graph positive means positive y values, so where's it above the x-axis? All right, so I'm going to factor this. So I want numbers that multiply. Get out of here. I want numbers that multiply to be 60. So this is AC method. And add to be negative 17. So I've set it up over here. And for sake of time, I've already found my factors. But I'm just telling you, I checked out 4 and 15. I checked out 2 and 30. So a lot of different things there. All right, so but I found that it should be negative 5 and negative 12 because I have to multiply to be a positive number, add to be a negative. So now I replace the middle with negative 5x and negative 12x. And I factor. So I'm going to factor out an x from this first one. So I'm putting these two together. Now I'm going to put these two together. Notice it leads with a negative sign. So I want to factor out a negative. And I'm going to factor out a negative 6. So 12 divided by 6 is 2x by negative 6. And 30 divided by negative 6 is negative 5. Remember, these parentheses have to match. And they do. So I have two terms. I'm going to take out the common factor of 2x minus 5, which leaves me x minus 6. I'm going to set each of these factors equal to 0 and solve. So I'm going to add 5 and then divide by 2. So that's 2.5. And then I'm going to add 6. Okay. So now I'm going to graph this and answer the question. So I have an x-intercept at 6 and at 2.5. And the question asks, where's my graph positive? My graph opens up, so that's important. It's important for this because it'll flip your answers around if you don't graph it correctly. So it's kind of bad, but okay. We get the point. All right, so this one says, where is it positive? So I don't want the middle because it's below the x-axis. I want the outsides because my graph is going up on the outsides. So I want negative infinity to 2.5 and 6 to infinity. Okay, that's it. I'll see you guys soon. Email me or drop your questions at the end of the video if you have questions from class. Bye, guys.